Chapter 17 and 19. Let's start the test, 8:30. I will allow up to 2 hours to take the test if you think you need it. I think if you come totally prepared for this test, I think you're looking probably at about 40 minutes. Okay. But I don't want to rush you. I expect most people to finish earlier, but there will be some performance-based stuff, and it takes time to measure and lay dimensions down accurately and all that stuff. Okay, so I'll allow up to 2 hours. Test is really going to consist of 3 parts. The first part will be multiple guess. Please don't answer C on all of them. There's going to be 30 of these.
30?
Yeah, and it counts for 60% of the test. We're going to, in essence, test in this section over all of the different guidelines and criteria and line types and dimensioning styles listed in 17. Following that, there will be a couple items that are specialty items that you will have to apply the dimensions to. And when I say specialty items, I'm really talking slots, chamfers, tapers, keyways, key seats, these types of items. We'll come back to that. There are 3 of those. The last part of the test, you will be provided with a completed 3-view drawing, and you will be asked to fully provide the size description of that drawing. Just as an aside, when you do the last one, the 3-view drawing, and you're providing the size description, dimensions, you may add only really one thing to the description. Keep in mind the shape description will be complete, but center lines can be added, right, to aid you in the dimensioning process. Okay, so if you don't like how the dimension or the center lines are done, and you find a way to use those to aid you in the size description, you may add those. But that's really part of the dimensioning process.
So we're not going to be asked to provide a multi-view?
No, you will not draw the multi-view on anything. It's all dimensions. That's the end of the test.
Really?
There is a bonus.
Oh, always.
I think you have 105 points total, of which 100 is what you're based on. Any questions so far? You will need your manual drawing supplies. You won't have to visualize, so it will be closed computer, closed notes, everything. All right, well, let's kind of go through it and see what it is. So the first part is going to be, in essence, definitions. We started the chapter by basically just jumping right into it, talking about what the size description was. What are our 2 dimensions that we always have to place for every object?
Location.
Location's 1,
Size.
and size. Keep in mind the size may be a location, but some items require both. On page 821, they talk about dual dimensioning. What's dual dimensioning? Not really metric. I don't want to use that because there's a lot of different units of measure out there. It's providing 2 units of measure on the same drawing, and you might want to look at the technique for that. We went over a bunch of definitions as spec'd out on page 822. Figure 17.5. Now this also went in correlation with another handout I gave you. Let me grab it here, if I can find it. So in essence, here's 17.5. Remember going over all these dimensions? And how we work on so dimension lines, extension lines, basic dimensions, reference dimensions, tolerancing, lateral versus direct. What's a basic dimension? How we do radii, how we do diameter, what's a meter line? That also referenced into this sheet that I gave you that had a bunch of our standards on them. And the only thing I really want to clarify, because they're basically the same, is that we do two differentiated things from ANSI, and actually there's only one from ANSI. ANSI requires that we have 3/8 off of the object for the first dimension line, and we extended that to a 1/2 inch for our first one, and then went 3/8 for all successive ones. That's the only deviation from standards. Now, the other caveat to this is your arrowheads. The ANSI standard is a closed-filled arrowhead, 1/8 inch long, width at 1/3 of that. But can you use other terminations for your dimension line?
Yes.
Most certainly you can. And ANSI recognizes those. But this is what everybody likes.
And that was one of my questions on all those different terminations, the dots. It says the surface. You know, you did this, and the one thing it says if you're describing a surface, you put a dot. I mean, what?
That's with the leader line, and that's the ANSI standard. With a leader line, we always point to an edge, right, with the arrow, okay, like what's shown here. If I'm dealing with a surface, ANSI states that you then put a solid filled dot. Okay. Now, it's very rare we point to a surface, but a surface would be something like this, right here.
Yeah.
Okay. Then I would use an 1/8 inch solid filled dot as my termination. That's what ANSI states.
Okay. And that's different than pointing to the joining surface where we're doing tomorrow and showing the edge.
Right. That's the ANSI standard. ANSI does recognize there's other techniques out there though.
Yes.
Okay. Because you will see other techniques. You're going to see some people use the tilde. That's what they use. In the architectural and civil world, when we point to a surface, we use a spline. Something like that. So there are other ways. The ANSI standard is point to an edge or use a solid filled dot point to a circle. But keep in mind, just like the dimension line, there are other terminations, and it is up to the employer to choose one. Stay consistent throughout the drawing. I don't know if those are called tildes. I think it is on your keyboard, top left.
Oh, I see it. That was for Spanish, the accent.
Okay, so just know all these standards, folks. Extension lines, 1/16, 1/8, tie to feature. We only break it around dimension lines. Dimensions, text preferred in the middle, arrows to terminate, 1/2 inch off, 3/8 after that. Our meter lines point to an object line, should come a 1/2 inch off, 1/8 inch shoulder. Our text is centered on this. By the way, I corrected this on a few drawings, and I should clarify this. I'm seeing some stuff on drawings where we have these specialty holes, threaded holes, counterbores, countersinks, and people are pulling leaders off, and they're putting their text where the leader is pointing something like counterbore diameter 3 depth, whatever. Okay? Where the leader line's pointing to the center. The leader line always points to the center of the first or last line, okay? So that we read it accordingly. We don't pull to the center of stuff. Okay? And I made a note of it. I don't think I docked anybody, but the ones I saw, I just made a note on your drawings of it. Always point to the first or last line. You can point to this one and then have it read up. Okay? You don't change the text. Okay? So let's say, let's do another one. Let's give it 3 lines instead of 2. Okay? So I can point to here and center the leader on it, or I can center on the first one.
I think I was guilty of centering the whole stack.
Yeah. I don't remember, but
This one,
let's just clarify that.
thank you.
That will really come up when we move to decimal, or our discipline-dependent drafting, because we use a ton of leaders in those types of drafting styles. Any questions on any of this stuff? And figure 17.5. Now, we do have some text. We talked about the protocols of text. And when we start pulling it out, as shown on figure 17.6, keep in mind on these figures with both the metric and the English units. This one's English. I think the metric one's a couple pages from here. C doesn't happen. Remember, on the dimension line, we do need an arrow and another 1/8-inch line, so this guy should never happen. So we want it like this. As it gets smaller, we leave the text in, pull the arrows out. As it gets too small for anything, we pull everything out. Does anybody know the difference between unidirectional dimension style and an aligned dimension style?
That's the bottom up.
Let me refresh your memory. 17.22 figure. Now do you know? Yeah, unidirectional is the ANSI standard. Aligned is still used also, but by the architectural field only. Pretty much everybody else has gone unidirectional. Following that, we have a bunch of symbols. You got your multiplier, typical, counterbore, countersink, diameter, square, depth, these types of things. So we've gone away from using abbreviations and gone with symbols, which I love, by the way. Much easier to do a symbol than abbreviate all these different terms. When I'm doing cylinders, keep in mind cylinders got specific dimensioning styles. First and foremost, a full cylinder gets a diameter sign. A partial cylinder or arc gets a radius sign. Your arrows switch based on those also, right? When I'm using a full diameter, my arrow points to the outside. I don't have a radius one, but if I had a radius, I want it with the arrow to the inside of the curve. You can look back at figure 17.5. They have some examples there. And then the other examples that are better are in the handout. Or the Gesicki handout I gave you, that one has the better examples of the radius. Positive cylinders are dimensioned in the rectangular view. Negative cylinders are dimensioned in the circular view, unless shown in section, and then dimensioned in the rectangular view. Leader line should be radial, as shown right here. That is for both radius and diameter. What else about these cylinders? Oh, always locate them in the circular view. I know we've had a little bit of issue with that where people were trying to locate those in the rectangular view also. And that's a pretty confusing view for location on any cylinder. When we've got a negative cylinder, and you might want to reference back to chapter 10, page 527. I better check that. See if my memory is, the old age has got me or not. I think it's 527. Yes, it is. 527 runs you through the blind holes, through holes, and all those things that dimensions mean with them. Okay, so know what these notes mean. Okay, that go with counterbores, countersinks, and how that dimensional information is all the size information that you need for these structures, or these features. Classic example, no depth is given on any negative cylinder. It goes all the way through the part. We give a depth, that's the usable part of the hole. It's not the whole hole, it's only the usable part. Primarily, we make holes with drill bits. We don't have to, there's other methods, but primarily we drill holes. That little end of the bit where it cuts isn't usable. It's not a functioning part. We also have these specialty items. We have chamfers. Keep in mind the liters are really kind of the best way because these are typically pretty darn small and it's hard to put linear dimensions on them. The liters generally work better. You have your slots, which by nature are the only item we double dimension. And it comes to the construction process. We did keyways, key seats. And then we also did tapers, so these are shown right here. Tapers, keep in mind, I won't turn there unless somebody wants to go there, but tapers, we do the diameter, length, and the deviation from the center line. Those are the three dimensions needed for a taper. They are not in your Bertolini text, they are only in the handout.
In that multiple page handout you gave at the very beginning of this section?
Yes, it's the one that, did I give you the first page of the chapter? I don't remember.
It's this one, Cheryl.
No, I didn't give you, this actually came out of, I believe it's the 8th edition, which is sitting on this thing over here, of the Gesecki text. Sad day when that gentleman bit the dust. What a great author. Had a great, great text. Threads. What are we going to do on threads? You're not going to have to draw anything. If you need anything on threads, I will provide a thread chart. If you need anything. I'm not going to say that they're on there or aren't there. What I'm primarily concerned at this point is that you can apply a thread note and you know what it means. So, in essence, I'll tell you straight up out of chapter 19, know the English thread note. And in fact, let me give you these 2 page numbers so you can refresh these. Page 913 has the English thread note. Page 917 has the metric thread note. So we're talking these two for the English. And then, as far as the metric goes, we're not going to the whole thing, we'll just deal with this one right here, the abbreviated one. Now you may, if you don't know what all these terms are, you may have to also go to page 911. Remember this one that had all the definitions on it? What pitch is, what major diameter is, what minor diameter is, these types of items. What does TPI mean? We went through the dimensioning techniques one day as a class, and we had people coming up to the board where we went over really the dimensioning process. I think we found out that there's a bunch of guidelines that go with this, and they are exactly that. They are guidelines, they're a place to start. But in essence, you take each individual feature, you locate and size height, width, depth, regardless of where they're at. You just do it. Then you go back and fine-tune the dimensioning process. Now, when we fine-tuned the dimensioning process, we went through a 3-step process. What were those 3 steps? Does anybody know?
Everything associative,
I'm sorry?
keeping things associative,
Contours.
What was the first one you said?
associative,
Yeah, associative was step 2. Contour dimensioning was step 1. So that's the most important. We want the dimensions where we see the profile of the geometry. That's contour dimensioning. Second thing we did was we went associative with it to where we pulled them in between so we could use it with both views. Then we did one other step.
grouping.
Grouping, where we grouped dimensions. Let's say we placed dimensions common to see certain features in the same location. That would probably be the best way to say that. So people aren't hunting for those. Okay, so first place all your dimensions, location, size, height, width, depth. Then do contour dimensioning, then do associative dimensioning, then do grouping, and the process should be then done, besides a review, going back and making sure you got all your standards met. Any questions so far? I think that ends the dimensioning process. From there, we went to tolerancing. Now, before I read dimensioning, I guess I should point out, starting on page 837, runs through 839, the author gives you 13 guidelines. And then we also pointed out at the end of the handout, there's another 57 of those. I asked that as you dimension, that you, when you finish a drawing, you would then go through those and kind of pick those things up. Some of the big ones in there, like don't dimension to hidden lines, don't provide gauges, things like this. I'm going to hit those in the multiple choice portion of the test. In essence, they're not really stated anywhere other than in these guidelines. I'm not going to let you use the guidelines when you take the test. Okay, so kind of review those. You should have already reviewed them if you're up through drawing 8 times. And you'll probably feel pretty comfortable with most of them. Don't worry, I'm not going to grab some obscure one that you might hit once every 30,000 drawings. Okay, we're going to stick with the big ones. Okay, but there will be a couple off there. Questions?
question and
Sure.
mention. A little bit shake on the typical, when you use typical versus the 4 times?
When we use the multiplier versus typical,
Yeah.
in my mind, the two kind of almost say the same thing. So we're really talking about 435, or excuse me, page 829 is where they have the multiplier. And they, if they have typical in here, I can't remember where it's at. I use the multiplier when I see everything on one view. Okay. The typical is a little more expansive. Then I'm saying, there's all these light features out there. It will be items that are undimensioned. And so I'm probably using typical when I'm asking them to go from one view to the next view to the next view, and all these items are the same.
Could it be on a different page or different
You
sheet?
can, they are somewhat synonymous in that you can use them the same place. Like could I use diameter 3.375 typical if this is a one-view drawing?
Yeah.
Sure I could. I can also use 4x. It's really a preference. One's probably a little more accurate than the other. If they've got all 4 of them staring at here and you say 4x, they count 4 of them, they know without a doubt they've got everything. If you use typical in this sense, then they would look at those 4 and then they would start looking, is there any others out there? and so they're kind of wasting a little bit of time. They do mean the same thing. One we're just a little more accurate with. I think the typical is better for a multi-view if you're asking them going from one view to the next. Because I might have 18 of them, and 4 are shown here with object lines. The rest would be hidden lines, or they're stacked underneath them, precedence, how we see them. And they got to go to another view to see it with an object line.